we are going to give a brief explanation about magnetic levitation.
Magnetic levitation, often called as maglev, is a fascinating technology where the objects float in the air without touching the ground, held up only by the magnetic forces by using the power of attraction and repulsions between magnet. It removes friction almost completely. This allows for the smooth, fast and a quieter motion, making it specially famous in futuristic trains. Beyond transportation, it also inspires engineering and science. It beautifully shows how invisible magnetic field can create powerful real-world applications.
There are basically two principles in this magnetic levitation: electromagnetic suspension and electrodynamic suspension. In the EMS, we use electromagnets on which the train attracts the ferromagnetic track and keeps the train levitated and stable. But in the electrodynamic suspension, it's a different case. In the EDS, we use powerful permanent magnets or superconductors for which the magnets repels to the track and keeps it levitating and stable. These are the respective diagrams for the EMS and the EDS. Here we can see the difference in the tracks and the making of it. Magnetic levitation has many examples, but we chose two of the most principal: maglev pencils and maglev trains.
Magnetically levitating pencils. The magnet levitating pencils works on the principle of magnetic repulsion, which states that like poles repel but unlike poles attract. When ring magnets are fixed both on the pencil on the base with the same poles facing each other, that is north-north or south-south, a repulsive force is generated.
This upward magnetic force balances with the downward gravitational force and makes the pencil float in midair. Since permanent magnets are not perfectly stable, according to Earnshaw's theorem, the pencil tends to wobble or tilt a bit. Thus, the pencil demonstrates a small-scale model of the magnetic levitation where friction is eliminated and the object floats due to the magnetic levitation. Secondly, maglev trains.
Maglev transportation trains, or simply maglev trains, uses a very large amount of magnets for the uplift and propulsion. This method has the potential to be faster, smoother and quieter than compared to the wheeled traditional system.
There are majorly four principles for the maglev trains, namely levitation, guidance, propulsion and braking. In the levitation, strong magnets create a strong magnetic field which either attract or repel with the tracks, and this cancels the gravity and lifts the train above the track. And in the guidance, the side magnets keeps the train centered and prevent from drifting off the tracks. In the propulsion, a system of magnet in the track change polarity rapidly and pulling and pushing the train forward. It is the same idea in which we use the daily motors, but stretched flat. In the braking, by reversing the magnetic field, the same system slows the train smoothly without physical labor.
Maglev technology shows that magnets are not just for sticking notes on the fridge, but for making pencils float and the trains fly. It makes the simple idea of like poles repel and turns it into the high-speed reality.
From a classroom demonstration to a futuristic transport, maglev proves that science can be both useful and magical. In short, magnets don't just attract, they also lift our imagination. Thank you. This is a magnetically levitating pencil apparatus. As we see here, if we drop the pencil, it falls down, but it floats here. How? The gravity acts on the pencil downwards, but the repulsion forces between the magnets acts upwards, hence balancing each other out and lifting the pencil in midair. This is a simplified form of this. It too has the same magnetic repulsions and gravity acting downwards, hence it floats up, but beautifully. And this is a simplified form of this.